All right. So again, I went back a slide. Let's just talk about what's happening here. I know the value of my hypotenuse completely. I know all of the top, and I know each piece individually. So now I can use this formula with the legs to solve for y or z. And I start solving for y. So I plug in my information. I've got hypotenuse over y is the leg I'm looking for, over y over x. Notice how x and y are on the same side? Okay. Now it's easier for me to look at this, keeping it as hypotenuse and x now, and then I can plug in my fractions later. So I do my cross multiply, I end up with y squared equals all this Momo jumbo. So now I plug in my information. I know that my whole hypotenuse is 50/3, and my whole x piece is 32/3. And now I can square root both sides. Now when I do that, it sets me up nicely because I can break this square root apart into lots of little square roots. And I do that by getting the square root of 9 on the bottom, and 50 breaks into 2 and 25, and 32 splits to be 16 and 2. Now 16 is 4 times 4, and 25 is 5 times 5. So I can pull those out individually, and we know that 9 splits to be 3 and 3. So that's just 3 on the bottom. So when I go to my next step here, you'll see I've got 5 times 4. Uh-oh, I've got a pair of 2's even. Check that out. I've got a pair of 2's. I can pull that out, and I'm left with 5 times 4 times 2 over 3. And that gives me 40 over 3. That's my y value, 40 over 3. Now I've solved for y. Which formula am I going to use to solve for z? Again, I know each piece of my hypotenuse. I know my altitude. But that doesn't get me the leg. I want the equation that uses the leg, okay? So now we're going to do that same process over again. We're going to use the leg. We're going to set up hypotenuse equals z times z over 6. Now notice I don't have to do the third issue over here like I did before because I'm using 6, because 6 and z are adjacent. Now I go ahead and cross multiply. I get hypotenuse times 6 equals z squared. I know my hypotenuse right here. That's no problem. Notice how the 3 and the 6 reduce would be 2. So I say z equals 100. I'm sorry, z squared equals 100. And then I do the square root of both sides, and I get z equals 10. All right, that's a great question. You won't have anything nearly this complicated using fractions so much, but I want you to see it's doable. All right, now your essential question. What are 2 skills you need for solving problems involving similar right triangles? You got to do, the hints are right here. What is this called? And then what is this called? Okay, so you got to be simplify and cross product. I just gave it to you. All right. For here, example 5.44, you're going to have this on your homework. The geometric mean between 6 and 18. Okay? I multiply them together and I get the square root. I factor them apart. 18 becomes 6 and 3. I've got a pair right there. I don't have to go any further. I can pull out the 6's and I get 6 root 3 as my answer. So now we're going to do geometric mean again. Show all of your work. We multiply them together. We factor each one apart. 3 and 5 and 5 and 7. I got a pair of 5's, I pull it out, and I'm left with 5 root 3 times 7, which gives me 5 root 21. There's my answer. So geometric mean right here. I've got, again, show all your work. Multiply them together. Put them under a square root. 81 splits to be 9 and 9, right? But that's a pair of 9's. This one's supposed to be 12 and 12. It's a pair of 12's. Now I can multiply those together and get 108. So the square root of these two numbers is 108. That's kind of cool, actually. So go ahead and fill out your summary of what you learned today. Don't forget this. This is free points. All right, and then coming up on the test on chapter 5, okay, you're going to have 3 problems involving square roots, 3 involving the Pythagorean theorem, 3 with the area of the triangles. Okay, that's including Pythagorean theorem. Okay, you have to use the Pythagorean theorem to solve for the area of the triangle. You're going to have 1 problem on triangle inequalities. From 5.2, you're going to have 4 of them on the converse of the Pythagorean theorem. That's where a squared plus b squared doesn't necessarily equal c squared. It's either bigger than or less than or equal to. And you got to tell me if it's a triangle, those types of questions. So you're going to have 1 problem on the large, medium, small angle. Okay. So find the largest, the smallest, and the medium. I think you've actually got 2 or 3 problems like that, but they're just in different formats. So now we talk about special right triangles. You've got 1 whole section of your test. is on special right triangles. That's the 30, 60, 90, and the 45, 45. Okay. So, and then section 4.5.4, you're going to have two of them on similar right triangle formulas. That's the leg over the whatever. They're on your cheat sheet. That's two of them involving the formulas, okay? So that's like what piece goes here, or what part is missing, or which of these formulas is correct, that type of stuff. Okay, then you're going to have three of them where you actually have to work out the formulas. And then you're going to have two questions purely on the geometric mean, where I'm going to tell you what's the geometric mean between 5 and 4, and you're going to have to tell me 2 root 5. Stuff like that, okay? So let's look here at this next slide here, the perimeter of a square. This is some good stuff you'll need to know. For the perimeter of a square, you're going to have to line up. I don't know why it's not writing anymore. I think I broke it. Yeah, I broke it. All right. Anyways, you're going to want to be able to know the area of a triangle formula and be able to match it up. So 1/2 base times height is your triangle. Trapezoid is your 1/2 height times base 1 plus base 2. The area of a rhombus is going to be your diagonals multiplied and halved. The area of a parallelogram is going to be your base times your height. The perimeter of a right triangle with legs AB. It's a great question. A plus B plus the square root of A squared plus B squared. This is an application of the Pythagorean theorem. This would be C. So A plus B plus C. Kind of cool. Something you might be interested in. That is your 4.5.4 ready for the test. I'm going to go ahead and start working on the review right now.